The topic that we are looking to cover today is realizing quicker and continuously with digital manufacturing. Uh, so let's look at first the typical trends or the challenges or expectations that are coming from all the manufacturing companies. One, of course, is timely deliveries. The second one is to be more efficient and continuous improvement from what you have today. So these are the three pressures which are building up more and more on the uh, customers. These are is the voice better now? I heard a feedback that the voice is a little feeble, so please let me know if it is better now. Okay, sure. So the three expectations that all the manufacturing companies are looking to achieve is having timely deliverables, then being more efficient, and having continuous improvement for from what you were doing yesterday. Now, with this in mind, let us look at what we can do to achieve this from the perspective of production optimization. So, production optimization helps you to get more from your existing plants. As we all know, it is not possible for just because that there is an increased demand that is coming. It is not possible for us to increase the uh, capacity through modes of additional asset or by adding more operators. Now, how can we profitable, uh, increase the throughput, and have a confident planning? So when we look at confident planning, it is about being able to deliver what we are committing within the timelines that you are looking at. Now, another area which is of high focus these days is coming in from the energy efficiency perspective, wherein customers are looking to have their plants to be able to be more efficient in terms of energy, which helps them save costs both in the investment as well as in the operations part of it. The another space which production optimization looks at is about having process optimization. uh, Initially, maybe you had one operator per machine, but as you go ahead, you feel that can I manage more than one machine with the operator now? Or maybe you are trying to reduce the cycle time of a particular machine by doing some Kaizen activities. Now, how is that going to impact your overall throughput? That's again something that is very important, or companies are trying to do on a continuous basis, uh, which is also helpful. Now, all of this can be achieved by looking at a digital twin. We'll see what is a digital twin in the coming slide. But before that, let us look at what are the decisions that uh, companies or manufacturing organizations are taking on a day-to-day basis. The demand of the product is not constant. It keeps varying based on different parameters, which can be one is of course a product life cycle. The next might be because of the it is a seasonal demand. Like if you take the case of air conditioners, the demand is more in the summers, while the demand might be lesser in the winters. Now that's also has an impact on when you're setting up your plant. How can you standardize or make a uniform demand, try to predict what is going to be your demand? Of course, that's something that would be taken care by the marketing teams, but how that is going to have an impact on your manufacturing facility is something that will be of interest. The second space is about can I reduce my work in progress inventory? This is something that is of keen interest from everyone today. Also, do I have enough tooling? what is the most optimum number of toolings? Sometimes we might feel that having more number of toolings will help us to produce more, but is that a reality, or is that going to be, you know, is something that needs to be validated? How can I minimize the changeovers? Where is the bottleneck? Which is a bottleneck station? How can I optimize the resource deployments? Again, something that is becoming more and more important today, when we have a lot of contractual employees. So how can you optimize that? Instead of having 10 operators, can I manage it with 8 operators? That's a big saving in itself. Now how can I try and do this? If you try to do this in your actual production facility, you are not sure how is it going to react to it. Uh, what happens if one of my machine fails? How long can I deliver? How is it going to impact? Where are the areas that I need to look into? How long can I run the plant at the same with the machine in a failed conditions? Then we spoke about having energy efficient plants, but it is also important for you to identify which are those machines which are contributing to the inefficiencies. And is it because it is wrongly loaded that it is inefficient, or is it because of a machine problem that it is inefficient? These are two different uh, problems in itself. Then we are more and more companies are today talking about going the way of automation. But automation, we should understand, is something that makes the system more rigid if not designed rightly. Now, what is the most optimum way of designing this automation system is again something that is important. And finally, uh, what are the ways that you can improve the throughput? So these are the typical types of questions which run within the different departments in the manufacturing organizations. And let's see how having a digital twin or using a simulation based approach helps you to address some of these questions, if not all. Before we get into the simulation approach, let's also take a look at how things are getting done today. Um, as most of you will accept, it is mostly uh, based on AutoCAD and Excel that uh, plants are built. Now, when you're looking at AutoCAD and Excel as a solution to build plants, it calls for involvement from very senior resources who have experience in building similar plants in the past. In addition to that, you need involvement from uh, consultants, system integrators, having a lot of group discussions involving the multiple disciplinary teams. And when it is a human brain that is doing, or when you are using Excel files, one, of course, is it is prone to errors. You need to be sure that all the formulas, all the calculation which is put into the Excel file is accurate at all times. And the same Excel file may not work for all kind of scenarios. Now you need to keep modifying your Excel files to meet each of this requirement. Also, there would be a lot of approximation that is being also done, because you might be assuming that the efficiency or of a particular machine is going to be 95%, or the OEE is going to be at 93%. Now, what if all the machines fail at the same time? How is it going to impact is something that we will not be able to predict using solutions like AutoCAD or Excel per se. Also, how does it add to the challenges? It is brain intensive. It takes a very long time to validate. Again, add it depends on the complexity of the lines, the number of variants that you are trying to handle in the same line. Um, it also calls for errors due to the approximation. And design from the automation, how the automation has been designed, whether it can handle more variants, lesser variants, how is it going to react to a change in the cycle time, and all of this. Another very key thing to look at is that all the results will be seen only after the investments have been made. So you need to have your plant that is built, and you have to ramp it up to your complete production capacity for you to understand how your system is going to be performing. So this is one of the key differences which will happen when you use a digital twin or a simulation based approach to build a plant, wherein you would be able to carry out what if scenarios well in advance, even before the first brick is laid. We'll see that in the next slides too. So what has changed from over the years in the industry? The time that you have to launch your products have reduced. We want to try and manufacture more products on the same line. The demands are increasing. Another important thing is, though the demands are increasing, the your end customer expects you to give it at a lower cost than what you supplied the earlier year. The demand is varying and sometimes unpredictable also. Very important thing to look at is increasing real estate costs. In the earlier days, uh, there was a lot of space that was available with the industries, so they could afford to set up a new plant as and when required, or a new line as and when required. But now that is not the case. The real estate is becoming limited, and it is also becoming more and more expensive as years are passing by. Companies who were earlier doing manufacturing in a single facility are trying to expand to multi geographies, trying to be closer to their customers, and also grow into more newer markets where the resource cost might be more. That means that you need to go the way of automated, and when you go automation, you need to be sure how your automation can handle whatever new variants that you're adding and other areas. What is the final objective of running any business is to improve the bottom line. So now with the top lines coming down, how can you still further reduce your bottom line is what we will see. So what Siemens talk about is a digital twin of your product, a digital twin of your production, and of your uh, performance, that is your actual plant functioning. Most companies today have already embraced the product digital twin, which is your CAD and CAE solutions. But still, when you look at the production and the performance, it is more to do with still the paper based approach or using Excel files. So now that's where you need to optimize and do things quicker, so that you can get to your customers at a lesser cost and in a quicker time. So how does digital twin help? One is in risk mitigation. So decisions are based on analysis and not on speculations. How? That is something that my colleague Varun will be showing you, how there would be a digital twin and you can see how your line is performing, what is the utilization of the different demands, uh, and those areas. Productivity and investment decisions. Can I do more or do better with the plant assets? That's exactly what is the biggest area that simulation can address. And how can you ramp up faster and without much of troubleshooting at the time of integration? This is again a space that a digital twin helps in addressing. So now let's get a little more closer to what and why you should perform production and logistics simulation. It helps in validating your plans. So today you might be generating your production plans using planning solutions or from your ERPs or even from your maybe from your Excel based approach. Now, if you have a solution or a digital twin, you can feed in this plan into that solution like plant simulation and see what is going to be achievable and what are going to be the hiccups, what are going to come, and how to address those hiccups, maybe through adding additional tooling or maybe adding more operators or trying to use something like a genetic algorithm, which is again a part of plant simulation to optimize your production schedule. Perform multiple what if scenarios to before you make a decision with respect to making a capex investment. You might be getting recommendations coming in from multiple suppliers. What is the most optimum recommendation, or do you want to further tweak this recommendation? That's again something that can be looked upon. Also, it helps you to predict the energy requirements which are there. Now, as I told in the earlier slide, that the major difference comes is you're validating your decisions even before ground break and avoid experimenting on your real factory. So this helps you to gain stakeholder confidence and also demonstrate to the stakeholders why you need investments to be made, and what is the importance and what are the different alternatives that can be looked upon. Now that we have a digital twin available with us, how can we use it on a day-to-day basis to improve our operations on a continuous basis, to be more effective and try and achieve timely deliverables to the customers? So the first one, which where you can use the digital twin, is to use it as a simulation based decision making, which is maybe to look at your production plan and visualize how your plant is going to respond to it. The second one is every plant keeps on undergoing changes. Before you implement these changes on your production facility, you can implement it on your digital twin and see what is the impact because of it. Is it going to give you a continuous improvement in the throughput, or is it going to reduce your throughput after the initial 5 hours or 6 hours? Or is there a trend that you are able to look at? And what is leading to that trend? Is it because of the number of pallets? Is it something to do with the operator efficiencies? All of that can be looked upon. You can also feed in your actual production data as an input into the uh, digital model and see where what went wrong and how can you correct that problem that has already occurred. So it's also possible to do postmortem of what went wrong and try to come up with the best solution to avoid it in future. It helps us to have robust production facilities and helping us save on the capex and opex expenses. So a very important thing which we all go through is designing and building production plant is a challenging task involving high investments, expertise, and having the right uh, team and suppliers, which also calls for efficient coordination between different members who might be geographically dispersed at different locations. How can you do all of that? And typically, all projects come up with surprises at the last minute, and this comes at a higher cost and a stress that is really avoidable. And that's exactly where digital twin helps to make the life of the project teams less stressful. Now that we have seen what is a digital twin, let's also take a look at what are the inputs that go into uh, building a digital twin, and what are the different kinds of scenarios that we can look at. So of course the inputs is the same as what you need to build a plant, which are your plant layout, your inputs regarding to your process, your standard operating procedures, your MTTR, MTBF values, uh, your your schedules, preventive schedules, setup times, all of this is needed. And then you would do a verification of the data, taking in your past data from your existing plant, or trying to generate a pro rata basis data, so that you are able to validate how your plant is performing. Now, once you have the plant ready, you can perform what if scenarios to look at the cycle time analysis. What happens if you change the cycle time of a particular station, or what is the impact due to buffer size change? How can you optimize it? What are the different alternatives? Perform what throughput analysis for a month, for 15 days, 30 days. Identify what is going to be the bottleneck, where is the bottleneck going to be, how can you avoid this bottleneck. Now you can also look at what are going to be your auxiliary system requirements. Look at your plant utilization levels, manpower planning, how many operators of a particular type do you need, um, what are the different types of skill sets that you need, and all this information you would get as outputs and scenarios. Now, to what level can I do a plant simulation? Now, though we talk about it as a plant level simulation, or the software is called plant simulation, you can do a complete network simulation right from your material coming in from your suppliers, to how it is reaching the transportation time can be also considered. Then your how it is reaching your stores, how it is moving from your stores to your production line, what should be the inventory levels maintained, or your complete network, uh, up to how you're delivering to your consumers or your customers can also be simulated in this solution. So that means that there's no restriction to what is a scenario that you can study. So let's also look at what are the benefits which plant simulation offer. It's a graphical modeling solution, so that means that you can look at your plant in a realistic manner, in getting in the actual CAD data of your machines to have a representation. Then support of investment decisions. Factory layout optimization is also something that you can look at. You can look at what are going to be your output quantities, what are the throughput times, the costs involved, the buffer allocations. Then we already looked at the inputs what are needed. Then enhance the productivity of your existing production facility, reduce the investments in planning of new production lines, cut inventory levels and the throughput time. A very important statement that you can again look at is plant is too expensive to be used as an experimental environment, and time is too precious to be wasted. So uh, with plant simulation, you can take your decisions of what you need to invest, when you need to invest, without having to buy your hardwares, or without having to make those investments. So just a slide with our customers. So you can see there are customers from different industries. As Suhasini mentioned, our customers are spread across verticals and geographical location. With this, I come to the end of my presentation. So next, Varun would take us through the product.
Hello everyone, it's Varun here. So I'll be showing you how the product actually looks like. I think you have seen the presentation, like how the product will be useful in your day-to-day application, and how it can be also be useful in your planning phase. So I'll actually show you how the product will look like. Yeah. I'm sure if I'm audible to everyone. Yeah, and if you have any question, you can just raise in the chat box. Even if I'm not audible, and if you're having trouble understanding or what am I saying, so you can just raise the questions on the chat box, so we can respond to it immediately. Yeah. So I'll be showing you a few examples how the model actually looks like in the plant simulation. So what you're seeing on my screen right now is the software. Yeah, and this particular layout is in 2D. So now the beauty of this particular software is you can have the model built both in 2D and 3D. Yeah, you can have the model built both in 2D and 3D. So so if you're comfortable with doing high level simulation first, then you can go with the 2D aspect of it, and then you can go on detail, then make the 3D models to make it more visually appealing, and make your model understand to someone who is very new to simulation, or who actually doesn't understand the line, how it works and all that. Yeah. So the model which you're seeing right now is is a line, it's a complete, closed loop line which has pallets running into the line, and it has parts also. Yeah. So okay. So what you see is this this particular lab, this particular line is made up of conveyors and station, and it has been, and all the particular constraints, for example, resource constraints and the automation constraint, and also the shift constraint has been put in to see like how it actually functions. So if I just run this particular line, yeah, so you can see the parts moving through the line. Now you can make it visually appealing. For example, in this particular case we have parts with different colors. In this particular scenario, different colors means different variants running into the line. Now what happens with different variant is, first of all, there's a setup time involved in the machines, and also the processing time for different parts or different variants will also change. So in this example, we have a part on the pallet which is coming, the pallet has been loaded from this line. Yeah, this particular point, you can see a mouse cursor, and the pallet goes through the entire line carrying the part, completing different processes, and then the pallet comes out of the line, sorry, the part comes out of the line and pallet recirculates. Now in this particular model, in this yeah, in this particular model, what we are trying to do is, we have built the model, and we are trying to see what is the optimum buffer required and optimum pallet size required. Yeah. So after you have built the model with all the necessary constraints, for example, speed of the conveyors. If I just open up and show you, yeah, you can put the length, width, speed, and that whatever time it takes, and what is the capacity of the conveyor. Yeah. So you can also put the failures if you have. In my case, I'm taking it as 100% availability. Okay. So you can put the failures and all the automation logics of the conveyors. Even for the station, we can mention the time. And one of the good thing about this software is like the time need not be constant. For example, if you have a semi-automatic station, then your time will vary between in a particular duration. So you can use this particular area to input that time based on the distribution. In our case, we have normal. Yeah. So it varies between 1 minute to 1.25 minutes. Okay. And then you can also put a setup time, recovery time, and then if you have any setups logic which is very specific to this particular machine, or it is very common, then you can set that up. You can also put in the failures. For example, in this case, in this machine, we have put a failure for around 98% and MTTR of around 3 minutes 20 seconds. Okay. So this particular model, in this particular model, we are trying to find out what is the max optimum number of pallets required to reach a particular throughput or optimum throughput. So there are many ways. One way is like you can run the model, you can see what is the throughput coming out of the line. You can see the throughput getting incremented over here, and then see the utilization of each machines. Okay, so I've just opened a utilization chart. Yeah, so whichever machines are running in the line, you can see this utilization being shown up here. So I'll just quickly explain what different colors means here. So green is the working, gray is starvation, or it is waiting for the parts. Red is the failure, yellow is the block. So here you can see, you can put up different statistics of particular machine and analyze and analyze and see what is going wrong in each and every machine, or how that particular machine is behaving. Yeah. And you can also see the buffer usage of whatever resources you want to see. So in our case, I'm seeing it for some resources and the time portion for which the MU stays at particular area. Yeah. And we have worker utilization chart, which will show you how each and every worker in particular line is being utilized. And also in the chart, you can see this light blue color, which means off shift. So if the simulation running in a shift where that particular worker is not allowed to work, so we can see that percentage of duration too. Okay. So now after we have built this model, after putting all the constraint, yeah, and we want to we can run the simulation for a particular duration. In my case, I'm running it for 1 day, but if you want to run it for 1 week or 1 month, that is also possible. So typically when it's a greenfield project and if you want to optimize a particular line which has too many of constraints and that data, and you have existing data from the line itself, so you can put all the data, run it for a month and see and analyze like what is actually going wrong and how you can optimize it. Yeah, because probably the line might be doing well in one particular day at a particular day for a particular variant, but if that particular variant changes, yeah, for the different plan, then you can run it for the whole month and check like how my particular line give me optimum output for different kind of variants. So in my case, I've ran this experiment. No, I've ran the simulation. I'm getting a throughput of 14.62. So after you build the model, after the model has been validated, so we can run various experiments to come at the optimum pallet number or optimum buffer utilization. So here we have set up an experiment manager, yeah, where you can plot the experiment with respect to certain inputs and outputs. So in this case, my output is a throughput, yeah, and I want to play with the variable known as number of pallets. So basically what it will do is it will give you a table with two values with how many number of pallets, what is the output you are getting out. And this particular experiments you can have with various randomized numbers. So it is not, it will not be a single value run experiment. This experiment will run with different random numbers. Yeah. So in my case, I'm going to run around 8 experiments with pallet number ranging from 15 to 15 to 50 in the steps of 5. Yeah. So once I run this, so it will give me a plot of like at what at how many pallet I get the optimized throughput. Yeah. And this particular experiment runs, it depends on the machines, like how fast you want to run or how slow you want to run it. Yeah. So in this case, I have set that experiment at one level. Yeah. So this is the way you can control like how fast you want to run and how slow you want to run the experiment, or how many experiments you want to run actually. So I'm running all the 5 experiments and we'll see like at how many number of pallets we get the optimized throughput. So yeah, so it has ran the experiment, and at the end of it, it gives me a report. It's a customized report which shows all the layout and whatever parameter we have considered. So after running the experiment, it shows me like at how many number of pallets, what are the throughput I'm getting out. So you can see here, actually, it's very surprising to see. So at 35, you get around 1462. Then again, it increases. Then it decreases as the number of pallet increases. Yeah. So at a particular stop, so we can see here at 40, we can stop at the number of total number of pallets. So with this, we can also infer if you increase the total number of pallets, obviously it will carry more parts, but there's a problem of traffic also. If you are increasing more pallet into the system, the pallet won't move at a particular duration. What will happen is if you just keep on adding pallets, the throughput will remain constant, and after that, the jam in the line will start, and then the pallet will not move at all. So with this, we see that at around 40, the 40 should be the ideal number to get the optimum throughput. Okay. So this is how we can see at what stage we have to stop and at what time we have to run the actual line. Yeah. So this is one way of getting the optimal number of pallets. Okay. So in this particular line, if I run and see, so this is how we get the output, and also some of the parameters which in gate is something known as energy analyzer. Yeah. So this is a new tool which has been implemented into the software. So what happens is you can put the energy parameters of each and every station. Okay, you can put the energy value of each and every station and see what is the energy consumption when you run the particular model for some durations. Okay. For example, in this case, when the machine is running in different stages, what is the total number of kilowatt being consumed by each machine for the simulation run? Okay. So I'll just show you how the input goes for these kind of results to come out. So if I open this particular machine and go to energy tab, I have to give all these values, like how much energy it consumes while it is working, how much it consumes while it is setting up, operational, failed, or standby, or when it is transitioning from one state to other. So once we have all this data, we can just put it in, run the simulation, and get this particular output, like energy consumption of all the resources. Yeah. So with this, we can infer like how best we can utilize our line and when to run our line so that our energy consumption is less, and at the same time we are getting the desired output also. Yeah. Am I audible now to everyone? Yeah. So this is the 2D layout which you saw, how we can build it and how you can see various graphs, how you can analyze a particular model, how you can optimize it, how you can run the simulations. Yeah. So I'm going to show you one more model. Yeah, where it's a again a 2D model, but the same comes in the 3D. But here the goal is to see which model gives the optimum throughput throughout the period. Yeah, not what happens is sometimes we build the line and it starts giving good output at the beginning of the day, but over the period of time the output drops. Okay, so in this particular example we have 4 models and we have one throughput plot here on the mail model, and this particular model is taking data from an Excel file. Okay. So I'll just open this one model and give a brief overview about it. If I double click this model, okay, this is the line, how it works, and I have 4 scenarios of the same line. Yeah, this is one model and this is second model. If you see the difference, the machine position in the first model, this ASK machines are on the top section, and then the ASK machines are on the bottom section. Likewise, I have some other models where some of the part movements have been changed. Okay, and then in this particular model between 3 and 4, you can see the distance from auto assembly to the quality check has been increased. This is a model 3 over here, and model 4 is over here. So we are providing a little buffer for the quality check. Okay, now what happens is if I run this simulation, I want to see the performance of all the 4 models on single plot. Yeah, so if I run this simulation, I can see the model running here, and also I can see the plot coming up here. Okay. Okay. So I can see the plot also coming up here. So now you can see, and different colors represent different scenarios. So you might see this particular red and green one perform very good at the beginning. Yeah, but over the period of time, green will perform better. So you can also see the blue one, which is the model 3. It performed very good at the very early stages, but over the period of time, yeah, so yellow one, basically the model 4 gives a good throughput over the period of the time. So so with this model we can see like which particular scenario will give me optimized throughput or good throughput or necessary throughput over the period of time, not at only beginning of the stages. So if I run it again, I can show you like how this plot has come up. Yeah, you might have seen some model were giving good throughput at the beginning, but over the period of time model 4 gave a better throughput. Okay, so this is how you can build up model, test out various scenario, compare all the scenarios and put them in a single window where you can compare and see and analyze and then take necessary decisions. So this was one more example which shows you the capability tool where you can build in with all the constraints. Yeah, and it has some other tools. For example, in this case I've opened this one in the bottleneck analyzer. There are small charts on each station which shows like for how long a particular station was working, how long it has been waited. So it gives you the overall view of how different machines were working. Yeah, and we have a tool known as Sankey diagram. You might be seeing a thick blue line running through the entire model. So this basically shows the traffic flow of each part. So wherever the traffic flow is more of each part, there you can see the thickened line, and wherever the traffic is less, there you can see the thin line. So this way you can also analyze, I mean, which line is occupied the most. Okay, so these are some of the tools which are available out of the box. But again, if you want some of the data which should come out and you need it in your case, then it can be customized in the tool itself. So some of the data, like if you want to check at each station what was the at each station each part coming in and going out, you want to record all those details and then plot and analyze. So that is also possible. So you can customize it and get out the customized report. Yeah. So this was in 2D. So now I'll show you how the plant looks like in 3D. So actually whatever you make in 2D comes up in 3D also. Yeah. So whatever, this is one of the plant which has various departments from painting to drying to machining, and also it has a warehouse and a dispatch section. Yeah. So when I run this particular model, okay, so you can see the part coming in from the input area, and you have a gantry which is picking up the part and keeping it over there. Yeah. And then you can see the resources also moving. So it allows you to it allows you to create very graphic, very appealing simulation which you can actually show to someone who doesn't understand the simulation very easily. Yeah, or doesn't understand line that easily. So this way you can also build the model in the 3D, analyze and show it to the customer or stakeholders how your lines are performing on, and actually how the line will look like. So in case of a greenfield project, if you want to show various departments working and how the parts will move from one location to different location, so this way you can actually show them how it actually functions, how it looks like, how the different station will perform, what necessary action has to be taken if you want to take before actually commissioning the line or the plant, and then go ahead with actual commissioning. Yeah. So in this example, you have a various area where the parts and pallets are coming in, and you can actually model the machine, how it will work, how it machines the part, movement of the man. Yeah. And various parameters like man speed, man face, and its efficiency can be put in. What is the capacity? Yeah. And where the parts are going based on the variants. Okay, so how the parts are moving between the buildings, and different material handling equipment, for example robots, UM. In this case we have something known as ASRS also, which is storing the parts after coming out of the line, and they're getting finally dispatched to the different area. So all these things can be put up and then analyzed, and also it can be visualized and seen in 3D environment also. So with this, I think you got fair idea about how this simulation actually works and how it looks like. So if you have any questions, we are open to it. You can put your question in the chat box, so we'll respond to it.
Once again, would like to thank all of you for taking time out and joining this session. If you have any further questions, we can take that up. And you can reach out to us with your queries, and we can take it up one-on-one as well. Please feel to write to us, that is either to marketing@renalsoftware.com, or you can get in touch with the concerned sales or the technical person you are in touch with already.